Hi, I'm Sofia. Sweet, thanks all for coming out tonight for the last and the third of the Backcountry Enabler episode about terrain. I'm super stoked to be working with RMU. Their goal is to be carbon neutral by 2025, and they're already producing skis in a carbon neutral factory up in Åre in Sweden, where I'm from. So if I have an accent, that's why. So this is episode 3, and it's going to be all about terrain. We're going to talk about making smart terrain choices, new ways of exploring terrain using mapping resources, and then applying the forecast and the weather to the line choices that we make. So the impact of weather on avalanche conditions. We'll talk about applying the forecast danger rating to terrain and line choices, how terrain changes avalanche conditions and spatial variability within that, how to make a trip plan, and navigation resources. So when we talk about a Pretip Research, a lot of you guys have seen this before. Choosing an appropriate objective for the conditions is kind of tricky, but it's super important. So the first thing we need to know is the forecasted danger rating. The second thing we need to know is what the weather and snow quality is like. And then when we know that, then we can choose what kind of terrain we want to go into, because those two things are going to dictate our terrain choices. And it's really important when you go through all of the steps of planning a day in the backcountry to go through that way and not the other way around. The weather conditions that impact avalanche likelihood. We got more likely ones, and we got less likely ones. So avalanche conditions that will make, or weather conditions that will make avalanche likelihood more likely are things like long and intense snowfall, when it snows 30 centimeters or more in 48 hours, rain, moderate to strong winds, rapid change in temperatures, warm periods, or when periods are about 0 degrees when the temperature is, and when it's really sunny. And then we have weather conditions that make avalanches less likely, like consistent light snow, periods of no snowfall, the freeze after a warm period. So on the 15th, it rained a bunch here. It's one of the first out of the 3 atmospheric rivers. It's the same one, but the 3 pulses coming through the atmospheric river hit us. And then after it got really, really cold. So avalanche danger went down quite drastically. We got calm winds, we got slowly cooling temperatures, extreme cold periods as well, and then cloudy weather. So the terrain makes the weather. All of the weather is created out at the ocean. And then that weather is going to move inwards in different weather systems. So we have high pressures that we sometimes get. That's when it's cold, clear, sunny, no limited precipitation. A lot of the high pressures that we get are generated in the north. That comes down from Alaska, usually associated with northerly winds, and they diverge weather, which means that if other weather tries to come in, they kind of keep a stronghold over a big flat area, and they kind of push other weather away, which is why it's always sunny in Calgary and in Alberta. And then we have low pressures where it's stormy and unstable and usually warmer temperatures. A lot of that is generated southwest of us, and it comes in. Our normal weather pattern comes from the southwest and moves to the northeast in BC. It's stormy and then it's unstable, usually warmer, and it attracts other weather. So if there's a low pressure system sitting here, it will pull other kind of small impulses of weather and humid air into it and keep snowing and snowing. And that's great, unless it gets too warm and too far south, because then it rains. And then we have temperature inversions too. And that's when the temperature increases with elevation, and we get sunny and higher temperatures up high. So when the weather moves in, we have orographic lifting. So the weather will move in and it will lift over the coast mountain ranges. That air mass now is going to cool. It's going to start snowing, and then it'll sink on the other side. It'll keep moving across. The flats now will go up over the Coquihalla again. It'll snow again, dip down. It'll pick up any moisture it can. When it dips down, it gets warmer, that air mass, and then when it rises, it cools. So that's what creates the weather that we see here. And then we have avalanche problems associated with weather conditions. So when we talk about weather, when we have cold, clear, humid weather, we often see surface hoar growth here. When we have moderate winds in the weather, we usually get wind slabs. When we have really strong winds, we can get wind crust, which can create a crust. It becomes a weak layer and a persistent weak layer eventually. Or we can get wind slabs further down where we're not expecting it. So we're skiing and there's nothing right at the ridges like we're used to, and then lower down we'll ski into stiff snow. Sun, rain, and warm weather will create sun, rain, or melt freeze crusts. When we have sun, rain, and warm weather, we might also get loose, wet, or wet slab avalanches because the snow is now saturated. When we have intense snow and wind, we get storm slabs. And then when it's really snowy, we might also see loose, dry avalanches if it's not coming in too warm. So when we look at the forecasted danger rating, there's a few questions we want to ask ourselves, and there's a few questions we need answers to be able to interpret it. We want to know what problem exists in the snowpack. We want to know in what terrain those layers exist. We want to know if there's been any signs of instability or recent avalanches. We want to know what the weather's been like, and we want to know what the snow quality is like. Those are all it looks like a lot of questions you want to ask yourself. But when I sit down and I try to look at the forecast, so if I've been away for a long time and I have a lot to look at, and I haven't been out skiing, so I don't know what the snow quality is like, I don't know what the weather's been like here, these are all the questions I need to ask myself. You need to know what you don't know, because if you don't know what you don't know, it gets super tricky. It's when people go out there thinking that everything is kind of fine and dandy, and it turns out that they didn't know that there was all these things going on that they had no idea about. Have everyone seen the avalanche danger scale? Because 3 considerable, natural avalanches possible, human-triggered avalanches likely, like human-triggered avalanches likely at considerable. I think most of us go skiing considerable being like, okay, I gotta be cautious, but like, it's not that bad. But like, human-triggered avalanches likely, like that's likely, period. So when we read the avalanche danger scale for heading out in the backcountry, you'll be able to read how many and what type of avalanche problems there are, how many elevation bands there are and what they are, and then define the aspects and the type of avalanche problem that we might encounter at them. So when we open up Avalanche Canada, you'll get this as the very first thing. So you gotta, well, not the very first thing, but as you click on your region, you'll get this. So you'll get a mountain. It tells you below tree line, and alpine. It tells you what the avalanche danger rating is for each of those different zones. At the very top, you'll have a little blurb, and that's going to tell you what happened to the snowpack most recently. That's the synopsis. So it's awesome to read. Like, read through all of it. It's great information. They're not trying to add extra words. Like, they're trying to tell you just what you need to know. So we want to know what the posted avalanche danger means in terms of likelihood of avalanches. The next thing you get to click on when you go from the danger rating to the problems is where the problem layers exist in the snowpack. So we want to identify and understand the problem type, the location, and the characteristics of that problem layer and the depth of it. So is this a problem that's 10 centimeters down, that is only in one small area, it's unlikely to size 1? Or is this a problem that is widespread, it's everywhere, so the chances of avalanches is very likely, all aspects, all elevation, and it's like chances are like size 3 to 4, so big avalanches. That's very different, right? Those are 2 very different things in terms of where we can ski safely and how we will manage terrain. And then we want to know what aspect elevation. It'll tell you what terrain you can expect to encounter these problems at. So I have to write this down, or I forget right away. And it's just like a prompt for myself to be like, okay, this is what's going on. Have a look at elevation bands, aspects, and their typical characteristics. So when we talk about below tree line, we're talking about like anywhere where it's really treed. Anywhere from here up until where the tree starts getting way more sparse. So in tree line, it's going to be generally warmer. It's generally going to be more sheltered. It's going to be less windy. It's just less affected to like the weather in general. And then surface hoar really likes to grow there. Surface hoar are these feathery crystals, and they get blown over with wind. So in the trees, especially in open areas where they have exposure to the sky, because they need clear sky coverage, because it has to do with radiation, you'll get surface hoar pockets. Not so much on the coast in general, but last year, and I can promise you this year, the more severe the weather changes get, the more we're going to get these. and we're going to have to get used to it on the coast. And then we have tree line, and it's like this really narrow band. So you can't take like a mountain and chop it into threes, like exact same like segments. Tree line is super small in comparison. It's kind of like right where things get way more exposed. So it's more exposed to the elements. It's a really thin elevation band, and it's like where it gets sparsely treed. And the reason why they have different avalanche problem there is because the weather is different there. And then you have the alpine, and that's way more exposed to wind and sun in general. It's just way more complex than the alpine because of that. And you'll have cornices, you'll have other terrain complexity like glaciers and all kinds of other stuff that adds to it. And then we have our aspects. So we have 4, for those of you who don't know. They're north, east, and then it should be south and west, but I wrote it like that for whatever reason. Either way, so we got the north one. North generally is colder. It's generally a little bit shallower of a snowpack. It gets stripped when we have Arctic outbreaks. So whenever you have a high pressure come in with northerly winds, the north usually gets stripped of snow and it gets deposited on the south. It's just shady and shallower in the general, and that will be potential for surface hoar, depth hoar, facets, all those kind of things that thrive when it's not moist. And then on the east and on the west, you get a little bit of sun still. So the east gets the morning sun. It's generally leeward. And then west gets the evening sun, and it's generally windward, so where the wind comes from. And then you have south, where you have a lot more sun exposure. It's generally warmer. It's generally a thicker snowpack there too. So if we want to figure out in what terrain these avalanche layers exist, they have something called the Avalanche Summary, and it'll actually explain to you what's been going on in terms of past avalanches in the areas. So it's great. Like, it tells you exactly what's going on. So please read these. And then we have the snowpack summary, and that'll tell you like what the depth and the reactivity of those problem layers are. If you're out ski touring and you've read this before and it's talking about a layer that's like 30, 40 down, like that's not very deep, right? Like, go and investigate it. Like, we want to try and go looking for these layers. And by that, I'm not meaning you going looking for avalanches. You want to go looking for the layers, which is very different, right? Because you can be on flat ground trying to see where those layers are. Like, use your poles, use your skis. Like, if you stop and have a snack break, like take a ski off and push your boot through, like see what it feels like to push your probe into the snow or whatever. All that kind of stuff gives you information about the snowpack. So when we want to know what the past weather, the snow quality in the forecast has been like, there's a weather summary as well that I would highly suggest reading. This isn't from now, but that's what it looks like. So please like have a look at it, read all 3 of those. Only after reading those, you're gonna know like what reactivity, what depth the problem layers are, where people have seen avalanches, like what type of avalanches they've been. Have they been remote ones, like across the valley, or have they been wet slides? Have they been skier accidentals? Like, if there's a lot of skier accidentals, to me, that usually means that people struggle to investigate or assess that problem accurately, right? So they're getting into trouble for whatever reason. And then at the bottom, it'll tell you too what the forecaster's confidence is. And that'll be the confidence both in the problem layers, in the snowpack, and in the forecast that's coming in. So when it says like high confidence, that's like he's pretty certain about what they're delivering to you. And when they say low confidence, it's usually because it's either an abnormally in the snowpack and really inconsistent in terms of like where we see avalanches and on what layer we see avalanches, or it's because the forecast is super inaccurate and they really struggle to figure out what kind of weather we see coming in. So when we talk about terrain and effects on spatial variability, there's a few different terms we kind of just want to think about. So we have incline, and that's the steepness of a slope, right? Steeper slopes kind of tend to shed snow versus like a bit lower angle slopes, like ideally 45 to 30 degrees, you'll see a lot of slab avalanches on, and then 30 degrees and less, it kind of becomes so flat that gravity supports the snow and it struggles to actually slide. Doesn't mean it can't. Exposure to wind, we'll see wind strip or low different slopes depending on what the aspects are. and it'll either pack the snow kind of into like a wind slab, or it'll pick up the snow, creating a wind crust, and it'll toss it onto the other side of the ridge. We talk about orientation to sun. So are you on a south aspect? Are you going to expect daytime warming? Meaning if it's sunny out, is that going to have a huge difference in the snowpack? Versus if you're on a northerly aspect, even if it's sunny out, the solar impact into that snowpack is going to be a lot less, right? Sun settles the snowpack, but it also creates sun crusts, which we get usually a little bit later in the season, not quite now in like December, January, but after that we get way more sun crust when the sun is more intense and higher up in the sky. When we talk about forest, it's sheltered from wind, so they become surface ore farms. Tons of surface ore, especially in the openings. Cut blocks are notorious, so like when they've cut all the trees down, they're notorious for being surface ore farm. So if I've been skiing all day in the trees and I hit a cut block, my brain just switches to it's not the same. It's never the same. It's really different, and it scares me every time. Maybe except because I'm coming from the Rockies and interior, where we deal with that a lot more, but we're going to see it more here. Ground roughness. When the ground is really uneven, it'll kind of tend to like bond the snow together because it'll snow and the snowpack is uneven, meaning the layer isn't unite. Then once all of that gets covered, we now suddenly have one persistent slope angle above that terrain roughness, and it's now not breaking up that layer anymore, so it's creating these planar, unique layers, and that's what we'll see avalanches slide on. And then you'll have stress areas. So if you have like a really big uniquely formed slope, and then have like a tree or a big boulder or something like that, there's a lot more stress in the snowpack around that, and that will now become like a weak spot. So usually you'll see avalanches going from like rock kind of to rock, or from tree to tree when there's only sparse trees or rocks like that. We have weather differences at elevations. So it's going to be colder generally higher up, and you'll have more extreme winds and weather. Generally warmer and less extreme weather lower down, so that affects the terrain, the snowpack, and the avalanche conditions massively. We have concave features and convex features. Concave is like this, so it's supportive. So gravity is going to help support that snow and that slope from sliding. And then you have a convex feature where it bulges over. And you see a lot more tension there because now the ground and the gravity isn't supporting the snow. It's now like kind of hanging. And you get like tension in that snowpack, and if anyone's like bent a pen and snapped it, or bent anything and snap it, we call about that tensile stress on something. That's exactly what happens to the snowpack too. That eventually it just like has too much tension, and it'll release, and you'll have a slab avalanche or some kind of avalanche on that. So we talked about trigger points a little bit when we talked about ground roughness. So any kind of rock outcrop, trees, or beneath the cornice, or that kind of stuff will be trigger points. So when we talk about trigger points, it's like where avalanches might start from. So all of that creates variability within the snowpack, right? So as much as you can look at a problem on Avalanche Canada, and then you can read like what the danger rating is, and where you see that problem, what the likelihood of avalanches is, and all that kind of stuff, spatial variability within all those elevations and aspects are still massive, right? There's so many other things when it comes to terrain we need to know. So assessing terrain accurately and being good at assessing terrain is going to keep us out of avalanches. It is the most useful tool. So like the more time you spend in weather, in snow, in the snowpack, looking at things and assessing like terrain and looking at terrain, trying different things when you're ski touring up. Like maybe there's a little pillow or like a little like mushroom, as we call them. You can like go jump on it, and a tiny little like rock that has snow on it. Maybe you can step on it and see if it's gonna slide or not. That will be a good representation of what the rest of the snowpack, if it has the same kind of characteristic, will be like. So understanding terrain, like I can't stress it enough. It's all about terrain, 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 and it's gonna be way more important than anything else you'll learn. The coast is really difficult for spatial variability because it differs a lot. So the Squamish area, which is the south coast on Avalanche Canada, we have then the Whistler Blackcomb area, which is the sea to sky, and then we have the Pemberton and Duffy area, which is the south coast inland. those are 3 completely different snowpacks. Like super different. So if you ski to see the sky all the time, like you kind of got to keep track of 3 different snowpacks all the time. You can't just like assume that if you're up the Hurley or up the Duffy that it's going to be similar to what it's going to be off the See the Sky gondola or the Squamish gondola. It's just not the same at all. And the reason why is because elevation changes and we're really close to weather. So we're right where weather comes in from the beginning and starts to rise. So looking at the weather forecast is really important. And then knowing that it's the hardest to forecast what's happening here because it's all depending on what's happening out at the oceans. When you're forecasting further inland, you've seen a specific weather system move across the province, and it's going to be easier to predict that than it's going to be predicting how much weather is going to get created out in the ocean and come in and hit us. Which is why quite often it'll forecast like 20 millimeters of rain and you'll get like 50 or 70. And it'll forecast no rain and you'll get 20 millimeters of rain. So you need to be really adaptable here, and you need to really keep an eye out for the spatial variability. You can't just read like a min report, or you can't just read something and assume that's what you see here. You just need to be a lot more aware. So other places to find information about conditions and stability, there's min reports. It's basically like a little blurb about the snowpack or about what they saw, what's going on. We talked about quality versus quantity in some of the other ones. In terms of quantity, there's a lot of min reports. Quality can differ a lot. Anyone can create a min report, so not specifically someone who has a great perception about what's going on. MCR reports are only created by Association of Canadian Mountain Guides professionals. So if you're going to read something, MCR reports and min reports will all be on Avalanche Canada, but you can also find MCR reports only in all of them if you search MCR reports. MCR reports are great. And then you can always go asking patrol too. Like patrol is awesome. Like if you're going ski touring off the resort, asking the patrol what's been going on, especially if they've been doing avalanche control the last few days, it's great information because they'll know tons about what's going on. And they'll also know what's been happening around them in terms of backcountry travel. Sweet. So when we look at weather resources, there's a few different things. So weather resources and forecast resources aren't necessarily the same thing. When I talk about weather resources, I'll talk about what's happening right now in the weather. So unfortunately, these should be flipped. We have the RP weather stations. So RP is created together with Avalanche Canada. It's like a 90s software. It's not computer friendly. It's like really quite tricky to use, but it has all of the telemetry stations. So telemetry stations will show you what's going on in the snowpack or in the weather right now. Each telemetry station is quite different depending on whose they are. So you'll see all of like forestry, highways, ski resorts, all that kind of stuff. Like all of those telemetry stations are gathered on RFE. So if you search RFE Avalanche Canada or go on Avalanche Canada, you'll find them. They're the only way to figure out what's going on right now. And then you'll have things like radar and satellite. They'll tell you like where the clouds and how much moisture is in those clouds, where they are right now. That's also like something we call like a nowcast. It can show you what's been happening up until now, but it won't show you what's forecasted. So Whistler Blackcomb has a telemetry station. So if you go on RFE or in Avalanche Canada, you can find Whistler Blackcomb telemetry stations. There is both for Whistler and for Blackcomb, but there's a bunch of different ones. It's awesome. So start using it, even if you're not going backcountry skiing, even if you're heading up to the resort, start using it. The more you use it, the better you'll get at it. And then we have forecast resources. So on the mountain weather forecast that's created with Avalanche Canada, you'll have like the 500 millibar flow, which shows you the more bright something is in color, the more moisture is coming in with it. Same thing, the more you look at it, the better you get at like kind of understanding it. And then we have other things like windy or spot WX, so the Whistler Blackcomb weather forecast. So Whistler Blackcomb gets their own weather forecast created by meteorologists, like it's paid for. It's awesome. So the one that's actually on their webpage is really good. It'll show you the freezing level. It'll show you the expected like temperature highs in the alpine, snow levels, and all that kind of stuff. So have a look at it and read it. Spot WX is windy, takes a little bit of time to like get used to, but start playing around with these and like find one that you like. And once you find one that you like, keep looking at the same one. Don't keep looking back and forward at different resources because it gets your head really confused. The more you look at the same one and it like becomes routine, the more easy it'll be to interpret it. So what we really want to do is try to figure out what kind of terrain to go skiing in. So choose terrain difficulty appropriate for the conditions is the first thing we want to do. We want to research the objective and alternative routes. Like we don't want to just have one route. We want to have a plan A, B, C. Like if I see this there, then I'm going to go here. If I don't feel good about that one slope over there, I'm going to go up this plan A or C, B or C instead. So have tons of different route plans, and then make a route plan using mapping resources. So if you've taken an AST1 course, you might remember this. It's a simplified way of looking at terrain, but it's still really good. So it gives you terrain ratings for intended trips. So if you don't have it, you can Google it. It's called Evaluator. We'll look at it in a bit. But simple terrain is like low angle. It has few glades and you have multiple options. Challenging terrain is like limited avalanche paths. Options are more sparse, but you still have options. And it requires careful route finding. And then you have complex terrain, where you have multiple avalanche paths, glaciated terrain, and you have very minimal options. So in terms of like choosing where to go, if you go on Avalanche Canada, they have resources there that will tell you what kind of terrain ratings different areas have. And if you're brand new to a zone or brand new to ski touring, it's a great starting point. When you're out there, try to look at the terrain and figure out what kind of terrain you're in, right? And you shouldn't head straight into complex terrain. However, the way Whistle Blackcomb is set up, it takes you straight into complex terrain. Doesn't mean that you necessarily should head straight out into the Alpine on big slopes where it's glaciated. So we want to try and use that danger rating and then use that together with the terrain rating. So combining both two to try and figure out where to go. So when you choose terrain, choose it based on the avalanche problems. By now, if you've followed all these steps, you should have an idea of what the terrain characteristics that you want to avoid are like, and therefore where you want to go. Use mapping resources and past knowledge to choose objectives that favor safe terrain. So I don't always use mapping resources. If I've been somewhere before, I can use my past knowledge. The more complex avalanche problems become and the higher the avalanche danger rating becomes, the more I'm going to revert back to terrain that I know. The less I'm going to go into new terrain. So when we look at mapping resources, we need to understand when and how to use them. And we need to understand what the benefits are to using them before, during, and after you're in the backcountry. We use them to try and figure out what the terrain looks like before we head out there. So many of these resources we'll have a look at soon. They'll show you what the terrain looks like before you get there, which is a massive advantage, right? You can use them for planning routes ahead of times, and they'll be able to tell you whether something is achievable or not. You can't be super objective driven in the beginning when you start out, but people see other people do things all the time, right? It's just like fed into your face all the time that you kind of feel like to be successful, you need to do the same thing without maybe understanding what goes into it, which by now, you know, is a lot. And like all of this goes on in our heads all the time. And this is like the end of presentation 3. Like I've already gone through presentation 1 and 2 in my head before we head out there. So there's a lot going on. We use mapping resources a ton for whiteout navigations. So either if it's getting dark or if you're in the Alpine when you don't have a lot of references on a glacier, like whiteout travel is its own beast. But a mapping resource is awesome because you can follow your own track back. You can always backtrack. So even if it's white and your trail is blown in, you can use these mapping resources to backtrack. And you can use them to find expected hazards. You can zoom in and you can see crevasses. You can see where the crevasses are, which are probably going to be a lot different after how warm this summer was. But you can see a ton of stuff. You can see glades in trees. You can see whether there's a cliff bend or not. There's tons of things you can see on these mapping resources. And when I had somewhere new, like I'm going to a brand new workplace now. I spent the last 2 weeks like hanging out on Google Earth, just like looking at terrain all over again, because I know it is the biggest and most challenging thing when it comes to making good backcountry travel decisions. So Google Earth is probably the one that's been around the longest, and it's awesome. It shows you 3D view in satellite imagery. It's really easy to make a route plan on it. It's super user-friendly. It shows you elevations if you just like drop a pin or if you hover your mouse over a location. It's probably easiest using your computer. This isn't something that you're using while you're out there. It's something you use prior to heading out there. This is a before resource. Okay. What you can do, and a lot of these people, a lot of guiding companies or a lot of people or the internet can provide you with a lot of mapping files with routes. Evan Stevens, a few other guys, they created a map for the Sea to Sky gondola backcountry last year. This year they're offering a KML or GPX file that you can download, and then you can bring it into Google Earth. And that's when you'll see, I don't know if you can see some red lines. Those are files like that. They can be either recorded tracks or made tracks on the computer, but they're great. Like I use them all the time. And then we have Gaia. Gaia is an app that you can use both before and during and after. I use it for route planning a lot, and then I use it a lot when I'm out in the field. It gives you 2D view though, meaning you can only look at things like you could with an original topo map straight at it. You can't like spin so that you are expected to look at it from different aspects. So the way you look at it, you just look at it from above, straight on 2D. So like play around with these at home, like record your track from the grocery store back to your house and all that kind of stuff. Then look at it in like 3D view or 2D view and try and figure out how it works. You have to have a subscription to use this one offline. It's not that expensive. And you can use different overlapping maps. So you can have contour lines and satellite imagery, which is awesome for me because those are the two that I grew up using. I use it all the time to create routes. So if I'm going to head out into the backcountry, especially if I'm going to head out into whiteouts or glaciers, I'll create routes all the time beforehand using maps, put it on here, and then it gives me a way. It gives me like a handrail or something to have if the weather shuts down on me and if I'm suddenly end up in a whiteout. And then we have FAP Maps, which is a little bit newer. It came out a few years ago and really just got big last year. It's kind of like combining the last two that we talked about. You have satellite imagery in winter terrain, but in 3D vision. It's a phone app you can get on your phone. It's also a subscription if you want to use it offline. Same thing, you can create routes at home, but you can also go and see like other people's shared routes and experiences. So you can read their trip reports, you can read their routes, you can read what they thought about that routes and all kind of other things. And it connects to Strava for those of you who really likes those KOMs or QMs or whatever they're called, the local legend segments. So when we use them during we're out in the field, there's a few dangers we kind of need to be aware of. And if you're walking around looking at your phone all the time, which a lot of people who are new using these apps kind of get trapped doing, you're really unaware to what's going on around you. So don't just get trapped looking at your phone. But it's really easy to miss like signs of instability cracking around you. Maybe like that avalanche over at that ridge that you didn't see because you kind of focus focus just goes into the small circle like right here. And you're not present during decision making. Using them too much or just looking at your phone is not the best way of assessing terrain. The best way is still being present right here, right now, and what's going on around you. So starting to use them before and after to reflect on your day is super important. So what I would do is I'd create a route plan on either of these. Then I'll go out and record a track. And then I'll go back and look at both of those and compare them and be like, where was the related terrain different than I expected it to be like? Did you anticipate the hazard accurately? And did you manage to follow the route plan that you expected? And was the time and elevation gain the same as you thought? So the more you use these tools, and the better you'll get at using them. But try to create a route plan for yourself, because only by doing so, you'll be able to assess how fast you move through different terrain, which is great when you use these apps, because it's really hard to try and figure out how long something will take until you know what your average pace is like in different terrain and different weather conditions. And then we have the original tools, and they're still great. There's plenty of books and maps out there. Like the stores around here sells them, and they're awesome. And we used to use these only, but we still use them all the time. Like any kind of navigation I head out on, when I'm expecting to actually have to use it, I bring a map and compass because I need to take bearings. And you can only do that with a map and compass. If you haven't created a route plan that you can just follow, you'll have to create bearings and try to walk off of them. It's the easiest way to try to walk in a line, because just walking, looking at your phone, figuring out if you're actually walking straight or not doesn't work. So if you're in a proper whiteout and you need to follow a bearing, so like a degree, you'll need to use maps and compass. There's no way of getting around that. Travel techniques and best practices. So there's a few different things we want to try and do when we're out in the backcountry that's going to keep us safer in general. We want to space out. We want to limit one person at a time to avalanche exposure. We want to go from safe spot to safe spots, meaning you want to try and ski so that you're out of avalanche terrain, but still be able to assist if you're needed for a rescue. So if you're looking at a slope and you're going to ski this together with your friends, you might look at it and be like, okay, well, this is really long. Hey, I'm going to ski down and then tuck into a trees over there where there's a bit of like a bump or an outcropping. So I'll meet you guys there and then we'll ski the rest of the pitch together because I can't see past this point. So ski to safe spots to safe spots. Plan an escape route. Like before I head into something, I will look down the terrain and I'm not just going to go. I'm going to be like, okay, if things go wrong, what's my options? Like, where am I going to go? And then try and stick to high ground, like ribs and ridges instead of gullies and depressions. Gullies and depressions becomes terrain traps in general, especially if you're skinning, so especially when you're going uphill, like stick to high ground. It's going to serve you really well to stick with these travel techniques and best practices. So to know and recognize terrain, we want to know what the terrain may look like before we go there. We want to anticipate what the snowpack problems and what snow quality might be where we're going. We want to know how the forecast will affect the terrain and the snowpack and the snow quality. So what type of weather is coming in. And then we want to start small and then work into bigger terrain. We don't start with the biggest objective. We start really small and then we can gradually, as we gain more confidence in the snowpack, work into bigger terrain. We've looked at this slide every single time, and I think it's really important. We need to know our physical and our experiential limits are. So we have three things. We have avalanche conditions, we have backcountry travels, and we have avalanche terrain. And when all those three work together, we get into an avalanche accident. But if you take avalanche terrain out of there, you can still have avalanche conditions and backcountry travelers in the field. But if you're not in avalanche terrain, you're not going to get into an avalanche, right? Or you might be in avalanche terrain and skiing, because most of good skiing is avalanche terrain, right? You just don't have avalanche conditions right now, which is why that slope is not sliding right now. Or you might have avalanche terrain and avalanche conditions, but you're at home drinking coffee and you're out of harm's way. So we have some human biases and hazardous attitudes that I think is really important to just familiarize yourself with, especially as we are in group constellations that we're not used to. We have familiarity, and that means, oh, I've skied here a million times, like nothing ever goes wrong here. This is like the safe spot. I always go here in high avalanche danger. And then we have acceptance. It's like I'm skiing with a brand new group. It's quite uncomfortable to speak up and really say what I feel. So it's quite easy to just like unknowingly, we don't do this intentionally, just not speak up about something that might just like irk you a bit. And then we have commitment, and this is why we don't choose terrain before we look at the forecast and figure out what the weather is like. I only have Saturday, Sundays off. We're going to ski Decker on Saturday, and no matter the weather, especially if it's kind of on the limit, you're probably still gonna go. Then we have expert halo, and I keep joking about this. If you guys all went skiing with me and I told you guys to jump off a cliff, you probably would. Just because you're out with someone that's more experienced than you, it's like really, you still need to think on your own. So be critical and ask them why. Like you don't have to say no, but ask them why. We want to make sure we don't get trapped in that like new person and the expert person kind of constellation. How many of you guys remember the big avalanche on the musical bumps last year? How many tracks was on that one that slid? A ton. And it was really scary, and I can't believe no one was involved in it. Just because this tracks doesn't mean we don't have avalanche conditions or problems. Maybe it hasn't snowed in 5 days. Maybe it suddenly got a lot warmer. We had a huge high pressure move in, and now avalanche conditions have changed, but it looks the same. Then we have social proof, do it for the gram. We got risk tolerance, which is inherently different and also different depending on our experiences. They need to be respected, and we need to, if we go out ski touring with a group, we need to cater to the lowest risk tolerance. So if I go out skiing with someone that's brand new, I'm not going to go and do what it's at my limit of my risk tolerance. Like, that's completely unacceptable. The only way we'll know that is by having a conversation before we head out into the field with the people we're going with, okay? Competition is like every day getting out from the ski resort into the backcountry versus the black humps. I don't think I have to explain that one. And then we have the hazardous attitudes, like the anti-authority attitude, like don't tell me what to do kind of thing. We have impulsivity, when you're just like acting on emotions rather on informed decisions. And then we have the invulnerability kind of thing, like, oh, not to me, it's not going to happen to me, kind of feeling a little bit invisible. We have the macho kind of like thing that you kind of just like don't want to listen to someone else. I think we all know what macho is. And then we have kind of the resignation, where like you may be just someone who's like quiet and like you kind of just like don't want to speak up because it makes it uncomfortable. You're equally important to the group constellation, so you need to speak up, and it can be uncomfortable, but please try to anyway.